talking on the topics related to social and demographic research. They are Allan Dafoe and Beth Novak. Our first speaker will be Allan Dafoe, Assistant Professor of Political Science at Yale University and Faculty Fellow at both the Institution for Social and Policy Studies and the Macmillan Center for International and Area Studies. Professor Dafoe's research examines the causes of war and statistical methods for credible causal inference. He won the Lemur Rosenthal Prize for Open Social Science as an emerging researcher for his work improving transparency practices. His PhD in political science is from the University of California, Berkeley, and he has an MA in economics from Berkeley and an undergraduate degree from McMaster University. So welcome, Professor Dafoe.
Thanks very much. Thanks so much. So it was a real pleasure to have Brian just share with us all the fantastic tools that they're building. And in many ways, much of what I normally would say to a typical audience, I am going to skip through because I think both this audience is more expert and in these topics, and also Brian covered sort of a lot of the motivation and sort of overall philosophy about transparency that I would otherwise say. So transparency is crucial to science. Science is a public enterprise, right? We need to make knowledge claims that are then interrogated in a public manner. But it's not just public. It's also requires that I trust that the claims that the community has accepted or that are sort of in some level of regard and esteem are reliable. The mechanisms of science have to help me know what claims I can rely on and which ones I can't. Otherwise, I have to sort of review every argument that I might want to cite or method I want to build on, and that's just not practical. But unfortunately, we know from cases of fraud and just neglect and sort of non-reproducible results, and in particular from the systematic study that of 100 replications in psychology, that on the order of maybe 20 to 50% of, say, experimental results do not reproduce in the sense that there might be no result there, right? It's actually zero, and the original result was a scientist finding noise, or the result is much weaker than the initial publication. Okay, so science is, we're trying to build this edifice, but it's only as good as the materials that are coming in. And we need a better process for screening those materials, right? A building that's built on uneven terrain or soft ground will not get very high. Similarly, a building that has materials with uneven quality. So I'm going to sort of rush through two aspects of this. One is sharing data and how we change the norms around that in code. The second is pre-registration and ways of thinking about it. And then I'm going to try to get to the third very quickly because I think it follows after Brian's talk in terms of thinking about what's the future of science, scientific conversation that a platform like OSF or others could build and could enable us. Okay, so we want scientists to share all relevant files for understanding where their knowledge claims come from, right? That is practical. Ultimately, I was thinking when Brian was talking, what is the utopia of transparency? Is it like a 1984 surveillance state where we have cameras on and everything gets shared? And I know one colleague of mine who really wanted to live up to transparency norms posted in their replication archive all the emails between them and their coders, their sort of coding history. So there was, thousands of emails. And so any critical reader can go and find out exactly why was this historical observation coded in this way and not another way. So that might be the limit. The transparency maxim I'll offer is that we should try to make every step of research as explicit and reproducible as is practical, right? Clearly, at some point, we're going to hit diminishing returns or other constraints. So we have to leave it up to each discipline and each researcher to negotiate that. But the benefits are tremendous. And I mean, Brian made most of these points. One I want to emphasize is the idea that scientific publications used to be like a scrapbook of photos of someone who went on a vacation or a travel, and they're showing us the pictures of their journey, and they're telling us a story from that. And that narrative is only as good as sort of we trust the author's representation of what they saw. And there the analogy is to data. Whereas with the internet, with modern computing, we no longer need to have this static representation of the data. Now I think of the publication sort of like an advertisement as like a guided tour. So the authors say, come with me, reader. I will walk you through a data landscape and show you what I found and show you what's there. But the reader should be free to leave the tour at any moment. They can say, I'm curious about what's over that hill or what's behind that curtain, and they should be enabled to do that. So I think that's where we're going, and just in terms of facilitating the reproduction of analysis. Okay, just a fun figure to share. So I collected data on, these are the 2 leading political science journals, and the y-axis is the proportion that state, or whether the article states that replication files are available. So a few takeaways. One, in the time period 2009 to 2013, at least if we look at APSR on the right, which is our #1 journal, it wasn't great. AJPS, on the other hand, started out at around 0 and then jumps to about 100%. And as you can probably infer, that's because a new editor came on board and added a policy that says all published AJPS articles need, the first footnote must state where replication files are available. So sort of a small commitment like that by a journal generated 100% compliance to the letter of the law, but not the spirit. So now the y-axis is, are replication files actually available? And nevertheless, we still have 50 to 25% of articles in AJPS, despite a footnote saying our replication files are available here. No replication files could be found there, or given about 10 minutes of searching anywhere else on the internet. Hopefully, I think the community is adapting. We see a creep up. And I should say political science has really embraced transparency norms and standards, in part because of the top movement, transparency and openness promotion guidelines. So we're getting better. But this is just to show that it really helps to have journals providing incentives. I'll skip that. Okay, so what do we want in complete replication files? We might want even the emails between the PI and the lab members, but I won't go that far. I do think we want as far down in the sort of chain of inference as possible. And you can think of it as we want to maintain a chain of custody of how the original data led to this final claim. And then one other point I just want to share that I think is symptomatic of the state of at least maybe political science, but maybe other social sciences, is that I work with surveys and survey experiments. And a key thing you want when you're reading a survey is to see the original survey text, the verbatim, how it's laid out, the question that preceded the key question, right? Because text can put the respondent in a different frame of mind. They interpret later questions differently. So we know this, that this matters a lot. And yet, to my amazement, leading scholars in my profession and my discipline will publish surveys and survey experiments without, there's nowhere on the internet is the actual survey text available. And so this is not due to technical difficulties, right? It is not hard to take a picture or a screenshot or produce a PDF of your survey, or a QSF file, for example, if you use Qualtrics. So I think what this reflects is either a lack of appreciation of the importance of this level of transparency, or people think they can get away with it, right? With some combination of the two. So Brian is great. He builds us tools to advance transparency. I will be a little bit more of the cynic or realist. I think we also need the stick, right? It's here we don't need a tool to get this happening. We just need colleagues to know it is not acceptable to produce a survey or survey experimental study and not share the PDF publicly, or the text of the survey. Okay, and we could even make stronger norms. We could have journals think that the paper should be retracted if it can't be reproduced from the original data. And then, of course, also, as Brian mentioned, we should find ways of weighting transparency in the incentive structure where it matters. We could rank and judge journals, and then when considering hiring and promoting scholars, we should upweight transparency as a criterion. Okay, so this is the beautiful figure about the 100 psychology studies. And the main takeaway here is, some replicated. The replicated effect was about the same as the original effect, but many did not replicate. The estimated effect in the replication was around 0. And this issue is not addressed by what I've just been discussing, the sharing of code and data, because this could be due to publication bias. It could be due to the researcher who runs 100 experiments and shares the 5 that are most interesting, right? So to address that, we need pre-registration, or there's some other solutions. And I just want to flag a trade-off in pre-registration that, unlike data sharing and code sharing, which I think is unarguable, there's very little sort of cost to it. With pre-registration, in my own experience, and especially with my students, there's a risk of spending too much time at the pre-registration stage and really slowing down the research process. So students will, because I'll give a very emphatic lecture about the importance of pre-registration, they will spend a month or 2 theorizing, and designing their study, and then when they do it, they get a null, right? So that's a month or 2, potentially wasted. Now, hopefully there's benefits, but the main point that I want to make is that a lot of science is exploratory and inductive. And like a lot of the value that's generated from science comes from the exploratory and inductive process. So we just need to find ways of preserving that value and recognizing that it's valuable at the same time as insisting that work distinguishes whether it's confirmatory or exploratory by systematically doing pre-registration. And then the other pitfall is that anticipating this time cost, scholars don't pre-register at all. So my recommendation is pre-register all the time, but don't require yourself to have a perfect pre-registration. Don't require it be a fully fleshed theory necessarily if you're not there with full pre-analysis code. I mean, that's great if you can do it, but if it's just one paragraph, that's great. And OSF, as I understand, as Brian's been using it, has sort of enabled that level of different levels of sharing. So you might have a summary minutes from your lab meeting, and that would be your pre-registration. And I think that's a good compromise. And yeah, there's other ways. Ben Olkin mentions, I think, a good way where you take out the treatment variable, and then you analyze your data. So then you get to see what the data looks like and how the outcome correlates with various covariates, but you can't p-hack because the treatment variable is not connected to the outcome. So that's a promising way. OK, and I might come back to that because do you know how much time I have? 5 minutes. OK, yeah. So I want to get to this. So this speaks to Brian's later slides, which are sort of what's the future of scientific conversation, right? And this idea that publication and evaluation currently are intertwined and should be separated is exactly right. And I'll just sketch sort of a vision that I think OSF is moving towards, and other groups are sort of starting to build out the features for this. And I'll tell you the vision that I think would be excellent, and I sort of think is an attractor for scientific conversation. And given how many scientists we have here, I would love your thoughts if this makes sense. So if I want to buy a book, here's Gelman and Hill's data analysis textbook. I can go to the Cambridge publisher's website, and what do I get? I get a title, I get their author name, I get the price, the cover art. I can look inside, so I can actually read the whole or much of the book. But what I don't get is what I started off by saying we need in science, which is the sort of synthesized expert evaluation of my peers and colleagues. Right? I don't want to have to read the whole book to decide whether I should buy it. I want to delegate to my colleagues who have already read it their judgment and then integrate it in some appropriate way. We now have that service. Amazon provides it for us. These aren't necessarily my colleagues who are doing this, though sometimes they are. But you have a community of readers who volunteer time to share their judgment and assessment of a book. Not only you have the quantitative ratings, which is a useful way to screen books, but you also have a detailed review and a holistic review. Amazon also helpfully gives us this, what did these customers who bought this also buy? which is a useful service that currently, at least the Cambridge website would not provide. So here's an article from our leading journal. And again, we get what the publisher provides. So we get the sort of details, the title, the abstract, the author name. But it's all shared. It's all provided by a self-interested group. The authors have a motivation to portray their results in a certain light. The publishers have a motivation to portray it in a certain light. There's no third party here telling me what they thought of this. And so that's where I think we want to go. We want to build a web platform or an online forum where the community discusses works, hopefully expresses them in a quantitative metric that can be aggregated in a sensible way to facilitate my assessment of other works, so that I don't have to spend 2 hours reading this paper to figure out if I trust the results or not. My colleague who already did that can basically tell me indirectly. So we have this more efficient conversation. This already happens offline, right? If I want to know if this works any good, I might email my colleague who I know has read it and ask them for their input. So we just want to build a web platform so that everyone has access to that, and it facilitates conversation. So here's one group that at least provided sort of a visual representation of what I think it could look like. This is Science Open. Here you have an article, right? The same title, authors, maybe an abstract. And then what I'm really looking for, right, is the quantitative summary of what readers think of this work. And then you can imagine a holistic review down here that's been upvoted by all the readers. So the first thing you would see is an expert judgment, third party, saying this is what I think of this piece. And it's not just a troll or a negative response. It's someone who really shares, this is what this work achieves, and this is where it falls short. These are the scope conditions. This is what's impressive. This is what you can look out for when you're reading this. Right? A third-party perspective that I can quickly get to, that's already been crowdsourced by the community, so that when I get there, it's at the top of visibility. OK, there's a lot of things we could add to that, and I'll just list some. So there's this idea of a wiki abstract, right? Rather than have the authors, who again have this self-interest in presenting their results as being innovative and outstanding, I would love to hear what expert reviewers think was actually achieved in the paper, right? What did the results actually show? So more disinterested representation. The ratings could be on importance, credibility, clarity. Those are 3 metrics that I think would be useful. You probably don't want just some naive averaging over everyone's ratings, especially if it's really open to the public, right? You wouldn't want to read like climate science quantitative ratings if a certain political group decides to get on there and downvote all of them, or even maybe one lab sort of systematically downvotes another lab's work. So you could have all kinds of customized ratings where you might subset on scholars of a certain achievement or a certain like social network. Entrepreneurs could even provide the service. They could say, use my ratings algorithm, which pulls from esteemed, respected scholars. OK, so then you'd have the community would upvote useful contributions, so that the first thing you'd see, like in Stack Exchange or Reddit or Quora or Amazon reviews, is the sort of overall most helpful assessment of the piece. But also contributors who are systematically helpful would be upvoted. And then every subsequent contribution that they make would be more likely to be visible. And conversely, contributors who are systematically writing ad hominem things or unhelpful comments would be downvoted and would have difficulties getting visibility. You could have a range of anonymity. So you could, though I think you'd probably want each user to have some kind of connection to an actual human identity. Though you could try with an anonymous model. But you could go all the way to a signed model where everyone has to use their real name. Though I suspect, given the prevalence of single-blind peer review, at least in science, we probably want to preserve at least some kind of blinded mode. So you could log in, make your contributions under a pseudonym, but the editors would still know who you are. And so that would prevent kind of collusion amongst circles of scholars who are upvoting or downvoting their rivals. It would help you identify trolls, and I think it would just help keep the whole process more productive. And then last fun idea to throw out there, for any metric that is like socially exogenous and really verifiable as sort of either 0 or 1, you could build a prediction market onto it. So the obvious application is replicability. So if there's an experiment that's done, you could have a prediction market for whether the experiment would replicate according to some standard of replication. Well, there's various ways, but if the replication is ever done according to some standard, perhaps by some consortium of labs, then the prediction market would pay out. So I think it's inevitable that science will go to something like this. There will be a much richer conversation in 5 and 10 years online. I can imagine it matters how we get there. Right? I can imagine there's path dependence. If we get there, if the scientists own the platform, it could be more productive than if a private company owns the platform, and the culture that we establish going in. So yeah, I look forward to your thoughts. And if anyone's really interested in this, I'd love to talk with you afterwards. Thanks.